In this particular given diagram, this angle is theta. So the block of mass m1 is being pulled towards the left hand side with a particular velocity v1. Let's say v1 here happens to be equal to 10 meters per second. The velocity of the block of mass m2 has been asked. So the way to solve this particular question is to understand that constraint motion equations are going to apply along the length of the string. So I'll write down the principle. So what is the principle over here? Constraint motion is to be applied along the length of the string. For the tautness of the string. For the string to be taut. Taut means stretched as opposed to slack. So basically, let us say that the mass m2 will have a velocity v2. So v2 is going to have this component along the length of the string, which is v2 cos theta. So v2 cos theta is how this part of the length of the string, this part, v2 cos theta is how this part of the length of the string is changing in magnitude. So this varies as v2 cos theta and this varies as v1. So since the string is taut, v2 cos theta is going to be equal to v1. So here simply v2 cos theta has to be equal to v1. Therefore v2 that has been asked is equal to v1 upon cos theta. Let us assume that theta was given to be, let us say, 45 degrees. Then in that case, in this particular given question, the answer would have been 10 divided by cos 45, which is 1 upon root 2. So the answer would have been 10 root 2 meters per second. Alright, so this is a similar kind of question wherein this block m1 is being pulled towards the right hand side with velocity v1 and the velocity of the block v2 has been asked. Here also the thetas are given. So basically this angle happens to be theta 2 and this angle happens to be theta 1. These two angles have been furnished for us, they are given. So basically let's assume that the mass m2 goes towards the right hand side with velocity v2. Now according to our principle that we have to use constraint motion equations along the length of the string. So the length of the string that passes over the pulley and goes towards the right hand side, this length is going to vary as v1 cos theta 1. So this is theta 1, so it's going to vary as v1 cos theta 1, and this length of the string is going to vary as v2 cos theta 2. So simply we can write v1 cos theta 1 is going to be equal to v2 cos theta 2. Therefore v2 which has been asked is going to be equal to v1 cos theta 1 divided by cos theta 2. The values of cos theta 1 and cos theta 2 will be given in the question, that has to be inserted in order to get the answer for v2. Let us look at this particular illustration. So here also let's say that this happens to be x1 for the mass m1, so this also is x1, We have seen the analysis of this plenty of times. So let us say this is the mass m1 that is moving downward with, let us say, acceleration a1. Now let's say the acceleration of this guy is a2. So this is the mass m2. The acceleration of this guy is a2, and this angle is given to be theta. So here the string will vary with a2 cos theta. So basically for the length of the string we can write down here, this is, let's say, x1, this also is x1, and this happens to be equal to, let's say, x2. Okay, so while we write down the constraint motion equations, we can write down x1 plus x1 plus x2 is equal to the length of the string. On double differentiating, we get 2 times a1 plus, now mind you, here we get a2 cos theta. a2 cos theta, because a2 cos theta is how the string is varying in the acceleration sense. This part of the string is varying as a2 cos theta. This is very important to understand. This is equal to 0. So this is one equation, and the next equation is, this is the tension T, right? The tension T is acting like this. So the tension T will have a component as well. So T cos theta is going to be equal to m2 a2. But actually, if we are taking constraint motion equations, then we'll have to write down minus T cos theta. This has been A4 explained. So basically, we take all the accelerations to be in the positive sense. So in that case, we'll have to actually take A2 as over here, because we have to take A2 to be going away from the rigid support. So if we need only the relationship, this is going to give us the relationship. If we need to actually solve it, then this is the correct equation for the mass m2, and for the mass m1 the correct equation will be m1g minus 2t is equal to m1a1. These three equations will give you the correct answer for a1, a2. So cos theta has to be known at that particular instant. So basically the solution for this particular question will be instant wise basically. So as cos theta changes, that particular instant changes, and then the next answer is different from the previous answer. This is a ring of mass m1 that is connected to a fixed vertical rod, and this is m2. So let us say this is going down with velocity v2. In that case, the ring would be going up with velocity v1. However, if this angle is theta, then the length of the string will be varying as v1 cos theta. Now v1 cos theta will vary as v2 essentially, because you can see that the particle that is moving in this direction has to then recede the string over here, and the string has to come downward in this particular direction. So basically v1 cos theta is going to be equal to v2. So let us say v2 is given and v1 is asked, therefore v1 is going to be equal to v2 divided by cos theta. Same principle that we have been using till now. Okay, so this is an interesting question wherein the pulley is, let's say, going upward with an acceleration, let's say 8 meter per second square. Now it is given that the acceleration, so these are the two blocks m1 and m2. It is given that the acceleration of block m1 happens to be equal to, let's say, 3 meter per second square in the downward direction. So these are absolute accelerations. So now the acceleration of mass m2 has been asked. So this is a clearly constraint motion kinematical question, and it does not involve any pseudo force. This is a trick question. We need to understand that, let us say the acceleration of m1 in a normal case, let us say when the pulley was fixed over here, then the acceleration in such a situation of the mass m1 compared to the mass m2 would be easy to find, or the mass m2 compared to mass m1 would be easy to find. If this was the situation, then if this is going down with acceleration 3, then this simply has to come up with acceleration 3. This via logic and physical intuition also we can understand. However, in this particular question the pulley is not fixed. So in order to understand, or in order to rather fix the pulley, we would rather take the frame of the pulley in which the acceleration of mass m1 will be in the frame of the pulley. It's going to be as follows. So this is 3 and this is 8. So the acceleration of mass m1 in the frame of the pulley is 3 minus 8 in the downward direction. So A1 with respect to pulley is going to be equal to 3 minus 8. So that will give me 11 in the downward direction. So according to the pulley, if we are sitting on the pulley, then the mass m1 is actually going down with acceleration 11. So by that logic, mass m2 will be coming up with acceleration 11 with respect to the pulley. This implies that acceleration of 2 with respect to the pulley is equal to 11 in the upward direction. But this happens to be equal to acceleration of 2 minus acceleration of pulley. So this is equal to 11 in the upward direction. So this happens to be A2 minus acceleration of the pulley. Acceleration of the pulley happens to be 8 in the upward direction. So this happens to be 11 in the upward direction. Therefore, A2 happens to be equal to 11 in the upward direction plus 8 in the upward direction. So this is equal to 19 in the upward direction. So students who are uncomfortable with this upward direction can replace this upward direction with j cap. So I could have written that this is equal to A2p, that is equal to 11 j cap. So A2 minus AP, this is the concept of relative acceleration, is equal to 11 j cap. So AP happens to be 8 j cap. So I could have written A2 minus 8 j cap is equal to 11 j cap. Therefore, A2 is equal to 19 j cap. Similarly, here we could have analyzed A1p equal to 3 is in the downward direction. So 3 minus j cap. Minus j cap represents this downward direction. Minus 8 into minus j cap. So this you get as 11 into minus j cap effectively. So this is acceleration of mass 1 with respect to pulley. So the ultimate conclusion is that the absolute acceleration of mass m2 is going to be equal to 19 j cap.